In this lesson, we're going to learn about Pythagorean Theorem. First, we're going to start by talking about the different sides of a right angle triangle. So the right angle in this triangle is over here, and in this triangle is over here. We need to know where the right angle is, and Pythagorean theorem is only for right angled triangles. Once we know where the right angle is, across from the right angle is the longest side, and that is called the hypotenuse. So from the right angle, right across from there, this is the hypotenuse. So this side, the hypotenuse, is the longest side, and it is across from the right angle. The other two sides of the triangle, the two sides that touch the right angle or that are perpendicular to each other and create that right angle, are called the legs. So these are the two shorter sides. And the two of them together make the right angle, or are touching the right angle. So on this other right-angled triangle, we have once again the right angle. Across from here is the hypotenuse. The hypotenuse we often call C, and for the formula that we're going to write down, we're going to use the hypotenuse as C. And then the two legs, the two shorter sides that touch the right angle, those two are called A and B. And it doesn't really matter which one you call A and which one you call B. So this one could be A and this one could be B. So Pythagorean theorem tells us that when we take the two legs and square them and add them together, that is equal to the hypotenuse, or the longest side, squared. So if we come over here, we can take a look at a few diagrams. So we have here a right angle triangle. So these are the two legs, the two shorter sides, and then across from the right angle is the longest side, and that is the hypotenuse. So we have A, B, and C. And when I square, which is literally taking a square, A times A, B times B for this side, and C times C, if I were to add these up, they would be equal to this square. And I can come over here and look at this one, where I can see that I have 3, 4, and 5 as my side lengths. So A is 3. When I square 3, I get 3 times 3, which is 9. This side length was 4. When I square that, I get 4 times 4, which is 16. And then the last side, the hypotenuse, is 5. And when I square that, 5 times 5 is 25. So that 9 and 16, when I add them up together, they are equal to 25. So what that means is that if we have a right angle triangle and we know two of the sides, we can find out what the third side is. There's another diagram here that shows you that these two together will make up the same amount as over here. So here we can see there's 9 squares together, and we see the 9 squares here. Here we have 4, 8, 12, 16, and let's check over here. 2, 4, 6, 8, 10, 12, 14, 16. So all of these, 16 and the 9 together, make up 25, which is the same as C squared. I'm not sure if we can watch this video here within the video, but there is a link here to a water wheel. We're on a wheel. We see this exact demonstration where this and this are filled with water, and when they're turned for the water to flow into here, you'll see that the amount of water that fills these two will exactly fill this side. So you can watch that demo through the link up here. Let's try a couple of questions here. So I'm going to leave the first one, and I'm going to start over here with B. So first thing is I need to know where my right angle is, and that is over here. and across from the right angle is my hypotenuse, which I have been calling C. And then the other two sides are A and B. So A squared plus B squared equals C squared. A is 25, so we're going to take 25 and square it. And then we're going to take 15 and square it. And that is going to equal C squared. So let's find out what 25 squared and 15 squared are. So 25 and, not sure where the square is, so I'm just going to do 25 times 25. And that's equal to 625. And 15 times 15 is 225. Now I need to add those two together. So 625 plus 225, and that is equal to 850. So 25 squared plus 15 squared is equal to 850. Now that tells us what the square is over here, but I want to find just the side length. That means I have to undo the squaring. And that I'm going to do with a square root. So I'm going to come back over here and I'm going to square root the 150. So square root 150. Now if you're borrowing a calculator from me, you're going to type in 150 first and then you're going to hit the square root button. If you're using your own calculator, you just need to check to see which it is that you need to do. So a good way to check is to type in your square root and then 25 and hit equals. If your answer is not 5, then try putting in first 25 and then hitting your square root. And in that case, you should end up with an answer of 5. So the square root of 25 is 5. You can use that to test with your calculator to find out which way you have to input your numbers. So, whoops, I need the square root of 850. There we go. So 29.15, and it continues on. I'm going to go just till one decimal place. So I'm going to end over here. I'm going to look at the number after. It's a 5. That means I'm going to round up to 2. So 29.2. If rounding is tricky for you, then don't worry about rounding. Just do one decimal place. So I'm going to write 29.2. But if you write 29.1, that's okay. So my units over here were in meters, so that means that this is in meters. So my hypotenuse here, x, is equal to 29.2 meters. So let's do another one quickly. We have our right angle. Across from that is C. So that means here we have A and B. So A squared plus B squared equals C squared. So that means 3.1 squared plus 4.8 squared is equal to C squared. So let's see what that equals. So 3.1 and 4.8. And let's just pop some brackets around here and put it all together. I think 4.8 was our other side. Okay, so that's equal to 32.65. And then now we want to square root both sides. So that's going to calculate C for us, and my units are going to be in centimeters. Okay, so 5.7. Now a quick check to make sure that your answer is reasonable is 5.7. This is the hypotenuse. It should be the longest side. 5.7 is bigger than 4.8. It's bigger than 3.1. If I add 3.1 and 4.8 together, That's 7.9, and this is smaller than that. So the hypotenuse should be smaller than these two added together, but it should be the longest side. Okay, let's take a look at an example where we know the hypotenuse, and what we don't know is one of the legs. So I'm going to call the leg we don't know A. So we know that a squared plus b squared equals c squared. If what I don't know is a and I know c and b, I can take b and move it over to solve for a squared. So I'm going to subtract from c squared b squared, and that's how I'm going to solve for my unknown leg. So a squared, I don't know. C squared is 17 squared, and I'm going to subtract 8 squared. We'll see what that equals. So 17 squared, subtract 8 squared. Oops. Okay, that equals 225. And if I square root 225, oops, then 15 is my answer. So 225 was the answer here. I need to square root both sides. So A is equal to 15 feet. Okay, we'll do one more like that. So we have our right angle. Oops. Across from that is our hypotenuse, and we have A and B. So we saw already that to calculate our unknown A, we're going to take our hypotenuse squared and subtract that leg that we do know and square that. So here we have 15 squared minus 10 squared. So 15 squared I just saw was 225. 10 squared is 10 times 10, which is 100. So 225 subtract 100 is 125. And now I'm going to square root that and solve for A. So 11.1, and I'm going to go one number after. That is bigger than 5. So this is going to become 11.2. So A is equal to 11.2 centimeters. Now, it does not matter that this is bigger than this, and in the picture it looks like this is smaller. These diagrams aren't drawn to scale. What's important is 15 is the hypotenuse. That should be the biggest number. It's bigger than 10, bigger than 11. And if I add the two small sides together, 11 and 10 are 21.2, and that's bigger than the hypotenuse. So the two legs added together should be bigger than the hypotenuse, but the biggest side on its own should be the hypotenuse. That's a quick way to check that your answers are reasonable. As you work through the questions, the answers to these questions you will find in Content Library, so they're not there yet, but if you come into Content Library Measurement, you'll see this page, Pythagorean Theorem, and you'll see answers to those. The rest of the questions, you'll see this third file over here is the answers to those practice questions. So you can use those to check your answers to see